Good morning, ladies and gentlemen, and welcome to the show. I'm going to talk about some unusual topics in this show and something that I've been wondering about for years. Uh, we all know, you guys know what primates are. Put a picture here of an example of a primate. You know, there's many different forms of primates. Most of them are what we refer to as monkeys or apes. Also, there was a species that walked the earth that was called a Neanderthal. Well, here's how my belief system is structured and how it works. I don't really believe in evolution, but I do believe in a process that's like evolution. Uh, Similar in many respects. I believe that this world is, in this universe that we're in right now, is all math. Math, that's right, math. I think it's all actually, the atom is a binary code. I believe this universe is digital. And I believe that the computer that generates this binary code also generates life forms on the planets through computer-aided design. Uh, and that this process takes into account, when it's going to make a species for a particular planet, it takes into account the gravitational field around the planet. It takes into consideration also the air, how much percentage of oxygen, how much percentage of carbon dioxide, how much percentage of all these different. It takes that into consideration when it develops the lungs through this aided design. And this process completes the species that it's designing for a particular world, according to the world that it's designing it for. And in retrospect, taking a look at these two things, evolution, what they call evolution, and what I'm talking about, this computer-aided design, through observing the two processes, they would seem to be identical. The major difference only being that one process is done with a thought behind it, in other words, the computer, in other words, intelligence. And the other process would be a process that's coming about through sheer chance, is what they refer to as evolution. But observing these two processes, they would be indistinguishable to the observer. So I believe that's what's going on. Now, it doesn't really matter so much what I believe. It doesn't matter that much, because the evolutionary process would be exactly identical. What the scientists call evolution would be exactly identical to the process that I'm describing, except just one's a mindless process and the other one has reason behind it. But for the use of this show, the rest of this show, I'm going to refer to that process as evolution. So I guess in a way I believe in evolution. It's just that I don't believe it's a mindless process. In other words, coming about by sheer chance. So we're going to refer to it as evolution. And this is where the problem arises, in my mind, is we observe the primates. Now, did you know that you can take an ape like a chimpanzee, and you can weigh him on a scale and say he weighs 100 pounds? His strength is 7 times as much as an ordinary man, weight for weight. So, if you were to take a 100-pound chimpanzee and put him in a cage match with one of these big wrestlers that outweighs him by about 3 times as much, the chimpanzee would come away victorious. And a lot of this is down to the bones. Now, where I'm going with this is, is, I believe, my personal belief is that when the computer, or evolution, we're going to call it evolution, because I said we're going to call it evolution at the start of this show. When evolution decides to create something for a particular planet, it takes into account things to consider like gravity and also the air. It takes in these things. It takes into what percentage of oxygen, what percentage of nitrogen, what percentage of so-and-so, you know. It also takes into consideration the food supply that's going to be available to the creature when evolution looks at all of these things, when it produces a species that's suitable for the environment that it's being put into. Well, the closest thing we can find to man on this planet is skeletons that we've dug up of Neanderthals and also the great apes like orangutans, gorillas, chimpanzees. When we observe all these things, we see the size of their bones, and this also determines their strength. But this all come about because this planet that we live on, we call a planet. I don't believe it's a planet. I know I probably just lost a lot of you guys. You guys are turning your ears off now. You don't want to hear this. I believe we're living on a sun. I believe that, like when I was in school, you know, I went up to the science teacher. And I was always a questioning kid. I always wanted to learn more, you know, about science and stuff. So I asked him, where does the heat in these volcanoes come from? And the science teacher said, okay, rub your hands together real fast. So I rubbed my hands together real fast. He says, feels warm? Hot? I said, yeah. He says, well, it's friction that creates the lava in the volcanoes. He said the plates, the Earth's tectonic plates, he said, are moving against one another. And this creates friction, and the friction is what creates the heat of the volcanoes. I didn't buy it. Didn't buy it back then. I don't buy it now. I believe we're living on a sun. And just like all suns, like our main sun that we have in the sky, the sun produces a lot of heat. But our sun's this sun that we're living on is a lot smaller. And it has a core. Just like the regular sun that's in the sky has a core. Very hot. Produces this heat through reactions. Nuclear reactions. That's produced in the Earth's core. And if we were, in fact, to have a giant bulldozer, say we had a bulldozer, the biggest bulldozer in the world, say it was like it was able to scoop up Earth down 20 miles deep. The blade went 20 miles deep. And say it went all the way around the Earth, peeled the Earth just like an orange, like you peel the skin off of an orange. And it's peeled off all of our crust, which is about 20 miles deep, our crust. And it peeled it off suddenly. In 1 second, it was able to go around the Earth, the bulldozer, and peel all the skin off. Then stand back and look at the Earth. You know what you'd see? A glowing orange ball. That's what you'd see in space. It would be revealed then. All of the packaging would be removed. Kind of like when you open up a present, you tear all the packaging off, and then the present's revealed. All the Earth, all of it would be revealed what it really is. It would be a glowing orange ball in space. A sun. Because that's where the heat from the volcanoes comes from. That's where all the geothermal heat comes from. So if our sun were to go out, pop, no sun anymore. Say our sun just popped out, turned off, like you turn off a light switch. Yeah, the Earth would cool very rapidly, but it wouldn't cool completely down to the sub-zero temperatures of space, the absolute zero of space. It wouldn't cool down to that temperature because our own heat from our own core would create a certain amount of geothermal heat to supplement the heat that was being received from the sun. And so, in fact, our core is actually supplementing the heat that comes from the sun all the time. This geothermal heat that's coming off of our sun that we're on. We're already on a sun. This is what I believe to be true. I believe that there's large cavernous spaces beneath the Earth where what's happened is as the core slowly cools, what happens is it has like what we call lava down there. As it slowly cools and these lava pools solidify, they contract. This is what things do when things cool down. Things contract. It leaves hollow spaces beneath the Earth. And as our core gets cooler and cooler and deeper, right now it's down 20 miles deep. You can imagine a time when the Earth was young and new, where there wasn't any crust. It was a glowing orange ball, or it may be even brighter. It might have been yellow even. As it slowly started to cool, it changed color. Turned from a bright yellow to an orange, and then slowly to a red, and then to a deeper hue of red that was almost not even be able to be seen except with infrared telescopes. And then ultimately it would get to a stage where crust would start to form, but crust would be very thin, and there'd be volcanoes everywhere. It'd be just like, you know, when the kids are out there and they're saying, the floor is lava. Well, the whole floor of the Earth would have been lava, mostly, except pools would have, areas would have formed where it would have been like islands. Now, if you can imagine a crust cooling and you're surrounded not by a sea of water, but you have an island that might be a foot or 2 feet thick of crust, actual cooled earth, of cooled lava, and all around you would be an ocean of lava. This is what the Earth was like in its early stages, as it cooled. And as it cooled, the crust got deeper and deeper, and thicker until it was uniform over the whole Earth. A cooled crust. Well, this cooling process still continues. So the crust is getting deeper and deeper, and as it recedes, as this crust recedes deeper and deeper, it creates pockets. Sometimes the pockets are just created from the fact that the hot expanding material of the lava and the heat coming off and gases coming off force an area, an opening beneath the crust and create caverns and things like that. So what happens is the ocean then slowly starts to run into these areas, cracks and fissures, and our oceans become more saline. Saline meaning more salty. And this is a process that will continue. Our oceans will slowly recede. And slowly our planet is becoming like Mars. Where do you think all the water on Mars went? It's the same deal. Mars is a little tiny sun. And its crust got thicker and thicker as time progressed. And the water receded under the surface to the point where the planet became uninhabitable. Now the same thing's happening to the Earth slowly. Our crust is getting thicker and thicker because I believe we're living on a sun. Now, where I was going with all this, getting back to what I was talking about, is the dense bone structure of these primates was designed to live on a sun. You ever seen how easy a chimpanzee can go up a tree? Doesn't matter if the tree doesn't have any limbs on it. The agility that they have, the strength that they have is amazing. They can just practically walk up the side of a tree. And this is because their bones are heavier than ours, designed for this world, designed specifically for the gravity of this particular planet, all these primates out there. Designed, I believe, by computer, but we're going to call it evolution. Designed by evolution. And evolution does not make mistakes. When it designs something for a particular world, it designs the bone structure to be the right dimensions for that particular creature. If it's a chimpanzee, then it's a chimpanzee. Following this belief of mine, which I believe to be true, what's up with mankind? Why are their bones so thin? This also determines why we're weaker. This creates a conundrum for me. A conundrum that can only really be solved in my mind by thinking that mankind originated on a planet that had a lighter gravity. Probably half the gravity of the Earth. In my mind, and this is a conundrum for me, because I think that the evolutionary process, we'll call it evolution. I don't explain to you why I don't really believe in evolution, but I believe that this process doesn't make mistakes. And so our species, Homo sapien, is not a mistake, but it wasn't generated for this sun that we live on. It was probably generated for something that had a gravity of half. And in that kind of environment, if we were put into a gravity of be half of what it is here on the Earth, we'd probably find it much easier. And in fact, then we would be able to probably climb trees and stuff like a chimp does, rather than rather than be so heavy. I believe that we survive on this world. In fact, we can almost thrive with our technological ability and everything. Our brains are so capable. But I think that there's a problem here. And I think that that creates a conundrum for me, is trying to understand why our bones are so thin and small in our species in relationship to other species that we can compare them to, that we know developed on this planet through the evolutionary process. Thank you guys for listening. I know this was a little bit of a different kind of show from what I normally do, but you know, normally I like to talk about Bitcoin and stuff, and the Fed's going through a tightening schedule right now, and cryptocurrencies are probably going to cool down for a little while. And anyway, listen, you guys have a great day, and we'll catch you guys in the next show. Bye-bye.